how software gets built, or the software development lifecycle.
You are programming with Palermo. You deliver software. You need to move fast, deliver quality, and run your software with confidence. Stay tuned for timeless solutions, simple methods, and topics that will propel you forward. And now your host, lifelong programmer, author, teacher, coach, Christian, and charismatic speaker, Jeffrey Palermo.
All right, so we are going to dive into the software development lifecycle, or in just layman's terms, how do we build software? This is a really old term called SDLC. You can see it all over the web, software development lifecycle, and lots of debate, but we're just going to drill it down. We're going to talk about how software gets built, and I'm just going to whiteboard with you, and let's talk about the different phases of it. There are so many job titles for people who work on software, developer, programmer, software engineer, and then there's DBA and sysadmin and project manager and tester and analyst and all that. But you know, for your own programming projects, you're doing everything. So let's dispense with job titles, which will never stop changing. That's why I'm a computer programmer. You're a computer programmer. Everybody's a programmer. Let's program some software. So let's talk about the different phases, the different activities that we have to go through, and then we'll break it down. So let's do that here. All right. So I like to use the Kanban style of phases. And so let's just break these down, and let's just make some swim lanes so that we can have statuses here, okay? And you can have more or less, but we're just going to start here. I'm going to call the first activity envisioning, and I'll come back to these. I'm going to call the next activity design. I'm going to call the next activity build. I'm going to call the next activity sell, then operate, then maintain. And there's always one later that circles back, and this cycle, and that's probably why it was called software development lifecycle. And think of it as improve. We're going to have ideas for improving. We're going to re-envision an idea for improving. Okay, regardless of the job title, let's say you are your own team of one. We need to envision a particular item. And so we have some capabilities of a piece of software, and we're gonna have let's say 4 things that we want a piece of software to do. Well, we're gonna take one of those and we're gonna say, okay, let me write down a little bit of information in here about what I want it to do, the concept, okay? The old terms, we would have called that requirements gathering, these fancy words. But once we kind of understand for ourselves what our overall goal is, we're gonna move it over and say, okay, now I'm ready to start designing this capability of the software. Now, design incorporates a lot of things. For example, I could think about how the user interface could look. Do I have screens? Do I have any number of buttons or inputs or whatnot? Is it a handheld smartphone piece of software? Is it on the web? Is it embedded into a car driving down the road? Is it a piece of digital signage on a screen hanging on a wall somewhere? How is someone going to experience that? And we have to design it, that software architecture, the structure of the system, the libraries that we're going to use, the languages, how many data points we're going to store in the back end. There's a lot of design decisions that we're going to determine, okay? And by the way, we do not have to design all of these cards here because we're not worried about those. Now, overall, you do want to make sure that you don't paint yourself in a corner, so that's a bit of experience. But we're going to design this particular capability of the software. Once we've designed it, then we're going to move into building it, okay? So we have our concept, we've envisioned it. We have the design decisions, and now we're going to do some activities to actually build it. Now, we can't start building it unless we actually understand the design. And the design is not just what it looks like or what data it stores. It also includes, when am I done? And so there's oftentimes in the design a good idea to put a checklist of test scenarios so that anybody who's looking at this thing knows the bounds of the scope. Every feature has a happy path, a exception path, sometimes multiple exception paths, and if you list out the different scenarios that software feature has to support, then everybody knows when we're done, as opposed to someone running through its paces and saying, well, shouldn't it also do X? Well, those types of decisions were made when we envisioned this feature, okay? All right, so now we're going to build it. We're going to write some code. We're going to put together those screens. We're going to do some automated tests, test-driven development. We're going to do some builds. We're going to deploy to some pre-production environments. We're going to build it, and we're going to get it out to our production environment, okay? This is fast forwarding a lot of, now, the next bit is we have to get it in the hands of someone who's actually going to use it. And I call that selling it. Now, maybe that's actually getting people to buy the piece of software, or maybe they've already paid money for it. They funded this project in the first place, and we're just delivering it. So when you think of sell, think actually deliver. Think there's a customer who bought this either ahead of time or now, and we're going to deliver it to them. Okay, we're going to let them start using it, get it in their hands. And so we move this feature over, and they start using it. Okay, now we want them to be really happy using it. And so in order to make sure that that happens, we have to operate it well. And so there are design elements that went into this. There are data points that went into this, but we need to monitor how this feature is behaving in the production environment, whether that production environment is the customer's smartphone in their hand or it's on a server somewhere. And so we need to monitor all kinds of metrics. And metrics are numbers, server response time, exception counts, things like that. And that's basically running it in production. Now, after we run it in production, of course, we're going to keep on running it over and over and over again. Every day, every week, we're going to talk about how well it's going. But at some point, parts that wear out, wear out. Every piece of machinery has a maintenance schedule. Every piece of machinery has adjustments that need to be made, bolts that need to be tightened, fluids that need to be changed, and the more complex the piece of machinery, the more complex the maintenance is going to be. There is not a single piece of business machinery that does not require maintenance. You might think, well, software really doesn't wear out, does it?
Programming with Palermo is brought to you by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient, moving fast, delivering quality, and running their software with confidence in Azure. If your team has a project that's too important to be delayed or derailed, ClearMeasure can help, while keeping your team in the driver's seat and growing in capability. Click on clearmeasure.com for more information. If you are an architect or .NET engineer aspiring to become an architect, check out clearmeasure.com/careers. Now, back to the show.
Well, think about this. In a vacuum, in an environment that never, ever, 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 ever changes, maybe you could make an argument for software not wearing out. But think about it. Does the software environment not change? I mean, a power outage could go out. This operating system is constantly being updated. The .NET frameworks that you're using are constantly getting updated. The libraries that you built it on are having new versions. There are bugs and vulnerabilities that are announced in some of the libraries that you happen to use. And so, yes, things break down. Not to say that your code stops doing what it used to do, but it was built for a particular environment, and now that environment changes, okay? So we have to do things to maintain it. We have to upgrade the libraries. We have to fix the security vulnerabilities that have been announced. We have to we have to redeploy onto a new operating system, a new framework version, and fix any compatibility issues. Every piece of business machinery takes some maintenance. And so when you're putting this feature out, think, does the way I designed this feature cause the maintenance schedule to change? Or are there any new maintenance tasks that are part of the software because of how I designed this feature? Okay, so you're going to have a maintenance schedule. You want to make sure that you maintain on that schedule. You know, the maintenance schedule could be super simple. It could be once a year when Microsoft releases a big thing, let's go run an extra test pass and let's fix any issues that we found. That could be it on some really simple pieces of software. On ever-changing things, if you integrate with some banks for payments and they're changing things, well, it may be more complex to maintain it. So it just depends on your software. And then to continue along to improve, periodically, and that's up to you, it could be once a month, once a quarter, once a year, periodically, we're going to look at the numbers of how this thing was operating. We're going to look at if the maintenance logs, if things went swimmingly or if we had any problems, moving it to new environments or upgrading libraries. And together, we're going to come up with some ideas. We're going to come up with some ideas for improvements, or it could be we're feeling a lot of pain and something's not working right. So guess what? We're going to have an idea for an improvement, and we're just going to bring those ideas all the way back, and we are going to create a new item here, a new card here, and we're going to say, I wish this pain wasn't as bad. I wish we could improve it in this way, and then we're going to prioritize that in. Now, I want to stress something. Notice how we didn't go from envision to design and start design on every feature we had envisioned at the same time. And we did not carry those over and then start building multiple features at the same time. Now, several decades ago, the software industry made a mistake and actually did that. They thought that was a good idea, but it did not go well. And so what we've learned as an industry is just taking one feature at a time through this software development lifecycle is the right way to go. Okay. Now, if it's not just you, if it's a team that you're on, every one of these stages, and again, I don't care what you call them, and you can break them apart. You could have 4 different design stages instead of just one. You could have, and you likely will have, a handful of build stages, not just one. But you take all of these major stages and make sure that you've accounted for them and make sure that there is a role in your organization that is responsible for items in that status. And once you do that, then your team will be working along. When there's a bottleneck, you can know exactly who to talk to figure out that bottleneck and build some software and do some programming. That was a quick rundown on how to build software, how software gets built, and the software development lifecycle. And thanks for being with me. God bless you, and thanks for programming with Palermo.
You've been watching Programming with Palermo, your primary place for highly productive programming protocols and practices. Remember, you have what it takes. You can do this. You are a programmer, formed by God Himself and called to this profession for a purpose. You can catch every episode at palermo.network as well as syndicated locations nationwide. We're so glad you tuned in. Until next time, may God bless you, and thanks for Programming with Palermo. Programming with Palermo has made a special arrangement with Marketplace Chaplains. Besides programming challenges, we all face issues in life where we need some help. If you'd like, you can call a chaplain confidentially. To speak with a gentleman, dial 512-923-8178. Or to speak with a lady, dial 512-619-6950. The show won't know you called, and everything is kept in strict secrecy. This is a free service, available if you or a friend need it.